Fellas, friends, you're back, and I am so happy you're here. Give yourself a great Acellus hug, because you are capable and smart and powerful and able to learn. You are smart and powerful and capable to learn. So let's get started. You'll never guess what we're going to talk about today. It is magnificent, and it's invisible, but it's with us all the time. You heard it here first. Invisible, but with us. It's there. It's there. It's everywhere. It's gravity. Now, the sign for gravity is a little funny. It's a two-part sign. Sign for gravity is this. Because here we have magnetism. Here we have the earth. It's actually the earth's ability to keep everything in place. This stays down because of gravity. This stays down because of gravity. The reason I'm not floating around the room is, you guessed it, gravity. The reason you're not floating around the room is, you guessed it, gravity. I have gravity. You have gravity. We all have gravity. The world has gravity. Now, big objects have big gravity. Small objects have less gravity. Do you know why the earth keeps us here? Because the earth is huge. Our planet is huge, and it keeps us down. It determines, and it tells this pen that it's gonna fall, because it has it exerts that invisible force that pulls everything down towards the center of the earth. Now, we have some planets in our solar system that are bigger than Earth, and they have even more gravitational force. They can pull things with more force, like Jupiter and Neptune. They really pull us down a lot more than the Earth would. But then there are things in our solar system that have less gravitational force, which means they don't pull us down quite as hard, like the moon. Do you know that you are much lighter on the moon than you are on Earth, simply because the gravitational pull, the invisible force that keeps everything down, is greater on Earth than it is on the moon. Now, if you wanted to take a walk on the moon, what would that look like? Would you just float away? No. The moon would still exert a gravitational force on you, but less. So you'll kind of bounce like this. You'll come down, but you would not come down at the same rate that you would come down on Earth. Isn't that interesting? This force that we depend on, this force that makes our lives so predictable, this force that lets us play the games we play and ride on buses and trains and airplanes, is invisible, but it's with us all the time. The Earth has a gravitational force that doesn't just pull you, but it pulls the moon. It keeps the moon in its place so that the moon doesn't fly off into outer space, or the moon doesn't come crashing into the Earth. It keeps the moon, I'll use a big word, equidistant, but it keeps the moon the same distance around the Earth at all times. The moon also, like I said, has a gravitational pull, and we see it here on Earth. Do you know when? The tides of our ocean. Have you ever been to the beach in the day, and, well, when you stood somewhere along the shore, it may have only reached your ankles, but when you went to that same exact place in the evening, it was maybe up to your knees or to your hip? That's because the moon has a gravitational pull on the water, pulling it closer into the shore. That's the invisible force that you and I experience all the time. We enjoy it. We get so used to it, we forget that it's there. But it's there, it's here, it's everywhere, and it's super powerful, It's called gravity. It's what keeps us pulled down and on the ground. Bye, Acellus friends.